Before the beginning, there was only silence. Not the silence we know between sounds, but the kind that holds the potential for everything, the pause before creation exhales. Imagine it not as emptiness, but as a breath held by the universe itself. From that quiet came dust, and from dust, the dream of a planet. A swirl of matter, half chaos and half intention, gathering in slow spirals around the newborn sun long before the oceans, before the continents had names, before anything could remember, there was this. A molten promise of a world that would someday call itself Earth. Yet the mystery remains, was this truly the beginning? Or is our planet the latest version of an older story, one told and retold through cosmic memory? Science whispers that worlds are born, destroyed, and reborn across unimaginable spans of time. The Earth we know may only be the latest incarnation of a pattern older than memory. Every grain of sand, every atom in your body, may have belonged to other worlds, forgotten Earths that lived and died before this one came to be. When we speak of beginnings, we often imagine them as singular. A first light, a first moment, a genesis written in fire. But nature is not so linear. It circles back on itself, weaving cycles of collapse and creation. The universe does not start once. It starts endlessly, reshaping itself in a rhythm we can barely sense. To imagine the first Earth is to accept that beginnings are not points, but waves, each one echoing through the deep fabric of space and time. The early solar system was no calm cradle. It was a furnace of collisions, a place where young worlds were constantly born and shattered. Among them spun a gathering of rock and iron, still soft with heat, still trembling with instability. We call it Proto-Earth, the embryo of our planet. But even this was not entirely new. The dust that formed it carried the remains of older stars that had lived and died long before. Supernovae had scattered carbon, silicon, and gold across the void, and that stardust fell together again, reforming into this fragile, glowing orb. In a way, Earth was never created, it was remembered. The gravity of becoming is a violent thing. As particles collided and fused, the growing planet fed on chaos, swallowing meteors, inhaling radiation, forging itself through impact after impact. Each collision left a mark, a memory written not in words, but in elements, pressures, and scars. The core began to form, heavy and molten, spinning faster as it condensed. The mantle churned like a slow ocean of fire. And above it, thin and fragile, the crust began to cool. What we stand upon today is merely the surface of that ancient fever. Somewhere in this molten youth, there may have been another world, one that came close enough to touch. Astronomers call it Theia, a planet the size of Mars that may have collided with Proto-Earth in a cosmic catastrophe. From that collision, our moon was born. If this theory is true, then the Earth we inhabit is not just our own. It is a merging of two lost planets, two histories fused into one being. Perhaps, before that impact, there existed a completely different world beneath the same sun, now gone except for the silent pull of its memory in the tides. And so, the idea of before Earth stops feeling like fiction and starts feeling like truth. The rocks beneath our feet contain atoms billions of years older than the planet itself. They have cycled through the hearts of stars, the dust of nebulae, the surfaces of forgotten worlds. Each element in our bodies has traveled through countless transformations before arriving here, now as part of this Earth. You are, in a sense, the continuation of other planets. The Earth that existed before the Earth we know may not have had oceans, or clouds, or even a sky. But it had the same potential, the same cosmic yearning toward complexity. Every planet is a question the universe asks itself. Can life exist here? Can memory persist through heat and pressure and time? And sometimes the answer is yes, whispered slowly over billions of years. As the molten surface began to cool, a fragile crust hardened over the chaos. The first rains may have fallen, steam condensing from an atmosphere of ash and fire. The newborn planet exhaled, and for the first time, silence broke. The Earth began to hum, not in sound, but in vibration, the subtle frequency of existence itself. It was the pulse of a being waking from a long sleep. And if you listen closely, that pulse still echoes today, in the shifting of tectonic plates, in the rhythm of waves against the shore, in the deep tremor of the ground beneath you. It is the heartbeat of every version of Earth that has ever been. All the forgotten worlds, all the buried ages, all the cycles of collapse and rebirth, they live in this one. This planet, this quiet sphere of oceans and memory, is the sum of everything that came before. The beginning, then, is not a point in the past. It is a presence, alive in every rock, every cloud, every breath. To stand upon the earth is to stand on the ruins of older Earths, to feel beneath your feet the slow, unending rhythm of becoming. And in that rhythm lies the first and oldest truth of all, that nothing truly begins and nothing ever truly ends. The first breath of stone was not a sound, but a movement, a slow gathering of matter in the void, a swirl of dust drawn together by gravity's invisible longing. Out there, beyond what we now call time, particles drifted like forgotten thoughts, colliding softly, then violently, until something larger began to take shape. The cosmos does not rush, it weaves patiently. What would one day become Earth started not as a sphere, but as a whisper, an accumulation of starlight turned solid. In that young solar system, chaos reigned. Everywhere, molten fragments of planets spun and collided in radiant silence. From the glow of the infant sun, ripples of energy pushed and pulled, sculpting orbits like invisible fingers shaping clay. Proto-Earth, a nameless gathering of molten minerals and metals, circled in the dust, growing heavier, hotter, more alive with each collision. It was not yet stable. It trembled with constant bombardment, each impact a heartbeat in the process of becoming. To imagine this world is to imagine motion without rest. Vast rivers of lava coursed across its surface, glowing brighter than fire. Iron and nickel sank toward the center, pulled by gravity's hand, forming the planet's first core. Above it, lighter minerals floated outward, creating a mantle and crust, a layered memory of its own creation. The air, if we could call it that, was thick with vaporized rock and metals, glowing red beneath a young and angry sky. Yet in that chaos was balance, an unspoken precision that would someday allow oceans, clouds, and life to bloom. Scientists believe that before our Earth, there may have been another version, a protoplanet that did not survive. Perhaps its orbit was too unstable, perhaps its collisions too violent. Some call it pre-Earth, a failed world erased by the same cosmic storm that later shaped us. Others say it merged with a twin, giving rise to the planet we inhabit today. It's a humbling thought, that our home might be built on the ashes of other worlds, their matter dissolved into our oceans, their stones now part of our mountains. In those early epochs, when space was still warm from creation, the planets were not the tranquil orbs we see now. They were restless, colliding, reforming, shifting their destinies with each encounter. And among them, Earth began to differentiate, to find its identity in layers of molten rhythm. With every impact, new minerals were forged, and through their cooling, the seeds of geology were sown. Rocks became the planet's first language, solid words written in silence, recording the birth pains of a new world. When molten oceans churned, they carried with them the memory of stars. The iron in our blood, the calcium in our bones, the carbon in every leaf that would someday grow, all of it came from stellar deaths. Each atom on Earth was once scattered light, a remnant of suns that had burned long before. In this sense, Earth's first breath of stone was also the breath of the universe reclaiming itself, turning flame into matter, and matter into memory. The planet's young surface was an inferno, but within that furnace, order slowly emerged. The rotation stabilized. The orbit found rhythm. The chaos of collisions quieted into structure. Gravity had gathered enough, and now it began to refine rather than destroy. The molten crust cooled in fractures, and through those fractures heat continued to escape, slowly, eternally. The first crust, fragile and new, floated like a skin atop the seething mantle. Beneath it, immense tides of magma shifted and rolled, preparing the stage for continents that did not yet exist. We often think of stone as still, unchanging, silent. But the first stones of Earth were alive with movement. They breathed heat, expanded, and collapsed. They broke apart and remade themselves over and over again. In their rhythm was the heartbeat of a young planet learning balance. If one could stand on that surface, though no life could yet survive it, it would have felt as though standing atop a star's memory. Somewhere in this primal fire, magnetism awoke. As the molten iron core churned within, it generated a magnetic field, a protective veil that would one day shield the Earth from solar winds. That invisible shield was among the first acts of planetary self-preservation, as if the planet were instinctively protecting its fragile possibility. The magnetic field would remain for billions of years, unseen yet vital, holding the story of that first breath in its invisible lines. In the stillness between collisions, there must have been moments of strange beauty, lava plains stretching endlessly beneath a red sun, shimmering with heat. The horizon glowed not with clouds but with vaporized metals reflecting starlight. The young planet shimmered like an ember in a dark cosmic hearth. And though it knew no life, it carried within it everything life would someday need: iron, carbon, oxygen, hydrogen, all waiting for their chance to combine, to breathe, to remember. In time, the violent collisions ceased. The fragments left over from planetary formation either joined the world or drifted away. The Earth's surface began to cool more steadily. Volcanoes continued to shape it, but now the planet had structure, an identity forged in heat and endurance. It was the moment when chaos became form, when the dance of dust became a body. The first breath of stone had been drawn. To breathe in the human sense is to take in air. But for the Earth, breathing meant solidifying, finding its rhythm of expansion and contraction, heating and cooling. Each volcanic eruption, each meteor impact, each pulse from within was part of that long inhalation of existence. The young Earth was alive, not yet conscious, but awake in its own elemental way. And so, in that molten silence, the planet exhaled. The crust thickened, the heat subsided, and the first traces of stability appeared. Beneath its fiery skin, a deep memory was forming, a memory not yet written in fossils or oceans, but in the texture of rock, the curve of minerals, the whispers of molten tides. Every stone born from that time still carries it, that faint echo of the moment the Earth began to be. To hold a pebble today is to touch the residue of that first breath. The atoms within it were forged in ancient stars, bound together in collisions older than memory, and cooled through the same timeless rhythm that still pulses in the heart of the planet. The stone breathes slowly, in ages, not moments. And through it, the Earth remembers what it once was, a glowing ember suspended in cosmic darkness, breathing itself into being one fragment at a time. Beneath the continents we know, beneath the soils, the cities, the ancient mountains, there lies a deeper world, one so old that it predates memory itself. It is not silent, though it never speaks. It hums in the slow pressure of stone, in the deep circulation of heat, in the quiet persistence of matter remembering what it once was. This is the hidden realm of the planet's memory, the ghosts beneath our feet. Every layer of Earth is a page in a book written in pressure, temperature, and time. But below the pages we can read, there are older scripts, buried continents, and submerged fragments of crust that have long since been folded into the mantle. Geologists call them cratons, the ancient cores of landmasses that once floated proudly on the planet's surface billions of years ago. These cratons are not dead. They drift slowly, like old thoughts beneath a sea of new consciousness. Some are still intact, forming the stable heartlands of today's continents. Others were pulled under, subducted, melted, and reborn as something else. To imagine these ghost continents is to imagine a world that has died and yet continues to breathe through another. Deep beneath Asia, beneath Africa, beneath the Pacific, scientists have detected vast structures that seem to defy explanation. Ancient slabs of rock, denser and colder than their surroundings, remnants of forgotten crusts swallowed by the mantle billions of years ago. They are like bones of an earlier Earth, buried within the living one. Through seismic waves, the planet tells us its secrets. When earthquakes ripple across the world, the waves travel differently depending on what they pass through. From these tiny vibrations, geologists can map the unseen interior of the planet, the mantle's texture, its hidden shapes, its ghostly ruins. What they have found suggests that some pieces of the earliest Earth, perhaps even from its first crust, still exist deep below. They have not melted entirely. They persist as shadows of the original planet, the Earth before this Earth. The mantle itself is a place of slow motion, slower than any human imagination can comfortably hold. Rocks there do not flow like rivers, but they move nonetheless, rising and sinking in cycles that take millions of years. It is a vast, living ocean of stone, circulating the memory of creation. In its currents, entire continents disappear and are reborn. The crust is consumed at subduction zones, dragged downward into darkness, where it melts, mixes, and becomes part of the deep planetary bloodstream. Later, it may rise again through volcanoes, through mountains pushed upward by tectonic breath. The Earth never stops digesting itself. If one could listen to the Earth, not through ears, but through patience, it would sound like a slow breathing. Each tectonic plate an inhale and an exhale, each earthquake a heartbeat, each eruption a whisper of buried stories returning to the surface. Beneath every continent, there are layers of older ones, like forgotten dreams lying beneath consciousness. When we stand on familiar ground, we stand upon ghosts. Some of these ghost continents have names. Zealandia, once a vast continent the size of half Australia, now lies mostly beneath the ocean. Greater Adria, another lost world, was subducted beneath Europe long ago, its remnants hidden deep under Italy and Greece. And there are others we cannot yet name, for they lie too deep, folded into the mantle where no light or human touch can reach. Each was once a world of mountains and rivers, weather and wind. Now they exist only as pressure and density, faint vibrations caught in the listening instruments of scientists who dream of reading the Earth's oldest chapters. It is strange to think that the planet remembers in this way. Memory, for us, is fragile. It fades with time, it bends under emotion. But the Earth's memory is physical. It is not a story told, but a structure preserved through endurance. Even when its continents are destroyed, even when its oceans vanish, even when the sky changes composition, the record endures in stone. Pressure does not forget. The mantle is not uniform. It carries scars, relics, and differences in composition that trace back to cataclysms long past. Some scientists believe that fragments of the proto-Earth, the very first crust that formed more than 4 billion years ago, still linger there. Others suggest that pieces of Theia, the planet that once collided with us, may also be buried deep below. If this is true, then the mantle is not just the memory of Earth, but the memory of two worlds fused into one, still coexisting in the dark beneath us. What a strange form of inheritance this is. A planet built upon the ruins of itself. The rocks we see today are not new, but reborn, melted and resolidified, changed and reassembled countless times. The mountain ranges that now pierce the sky were once seabeds, crushed beneath unimaginable weight, transformed, and lifted once again into the light. Every stone is a survivor, carrying the chemical signatures of its previous forms. If we could follow a single grain of mineral deep into the mantle, we would watch it descend over millions of years, subducted beneath the edge of a tectonic plate. As it sinks, the temperature rises, the pressure mounts, and the structure of the mineral changes. It may fuse with others, it may melt entirely, it may linger for eons in that molten twilight before being forced upward once more. When it finally returns, perhaps as part of a volcanic eruption, it carries with it whispers of the deep. Scientists call these mantle xenoliths, pieces of the unseen Earth brought back to the surface, carrying clues about the ghosts that dwell below. And yet, even as we uncover these mysteries, we realize how little we truly know. The deepest humans have ever drilled is barely 12 kilometers, only a scratch on the surface compared to the planet's full depth of over 6,000. We live atop a skin of rock thinner than the peel of an apple, while beneath us lies an ocean of stone vast enough to hold every secret of creation. We cannot touch it, but it touches us constantly, in the gravity that anchors us, in the heat that rises through the crust, in the magnetic field that shields our world from cosmic winds. Perhaps memory, at its truest, is not about holding on to images or facts, but about the persistence of being, the refusal to vanish completely. The ghost continents beneath us are not gone. They have merely transformed just as all things must. They live in the pulse of earthquakes, in the slow drift of continents, in the warmth of the mantle that still glows beneath our feet. The Earth's body remembers through movement, through change, through its endless cycle of death and renewal. And so, when we walk across the ground, we are never truly walking on one Earth, but on many layered worlds, buried civilizations of stone, ancient geologies asleep in the dark. The planet beneath us is not static. It is a vast archive of transformation. We are, every moment, standing on the memory of fire, the remains of vanished worlds still breathing quietly in the depths below. The ghosts are real, and they are alive, not in form, but in persistence. The Earth carries them with reverence, as we might carry our own forgotten selves. When the sky was made of fire, there was no blue, no soft horizon, no gentle clouds drifting above the newborn world. The air itself glowed red, heavy with ash, sulfur, and iron. The planet's surface simmered in molten seas, and the sky mirrored that heat, a furnace above a furnace. It was not the world of oceans and forests we know now, but an ocean of flame, where stone flowed like water and water could not yet exist. To look upon it then would have been to look upon the inside of a star, the raw, unfiltered breath of creation still burning from the planet's birth. The early Earth was not peaceful. It turned beneath a young and violent sun, bombarded constantly by asteroids and comets left over from the solar system's formation. Each impact reshaped the world, throwing molten debris high into the sky, where it rained down again as liquid fire. The atmosphere was a suffocating veil of steam, carbon dioxide, and volcanic gases, methane, ammonia, hydrogen sulfide. It was thick, hot, and luminous, glowing like a red furnace from within. The sun's light could barely pierce through it, filtering into a dim, perpetual twilight. And yet, in this fiery chaos, the planet was forming its first language. Volcanic plumes rose from cracks in the crust, exhaling gases that would one day create air and oceans. Lightning flashed endlessly across the smoky horizon, igniting chemical reactions that forged new molecules from chaos. The young sky was not merely a bystander, it was an alchemist. In its burning haze, the first compounds of life's story were quietly being written. Imagine the horizon then, no true dawn or dusk, only a constant shimmer of heat and radiation. The oceans of magma rolled slowly, crusts forming and breaking in an endless cycle. Each eruption bled metal and mineral into the thick air, feeding the growing atmosphere. What we call sky was, at that time, more like a living furnace, a dense, turbulent layer of fire that merged with the planet itself. There was no boundary between heaven and earth. Both were one molten body, breathing together. Some scientists call this epoch the Hadean, named after the underworld of myth. It suits the imagery well, a realm of fire, transformation, and rebirth. But even in myth, the underworld is not a place of punishment. It is the realm of change, where old forms dissolve so that new ones may arise. The Hadean Earth was the same. From its infernal heat, the foundations of the future were being laid. The crust that cooled from these magma oceans became the first stone skin of the world, thin and fragile but strong enough to hold the dream of what was coming. Volcanoes erupted continuously, their fury shaping the planet's face. Rivers of lava carved valleys that no human eye would ever see. Beneath the molten surface, elements mingled. Iron sank deeper, silicates floated higher, and the mantle's great convection began. It was here that the Earth's inner systems were born, its core's magnetic field, its cycles of heat, its restless tectonic energy. All of this, the invisible machinery that sustains the planet today, was forged in that fiery beginning. The sky of fire was not only heat but light. Auroras of plasma danced where the magnetic field began to take hold, shimmering across the toxic air. Solar radiation flooded the planet, unfiltered and fierce, yet that very radiation helped drive the chemical evolution that would someday give rise to life. Energy is never cruel or kind. It simply transforms. The fiery light that seemed to devour everything was, in its own way, the sculptor of possibility. There is a strange beauty in that thought. The same forces that could destroy life before it began were also preparing the stage for its birth. The volcanic gases, the lightning, the searing sunlight, all combined to create the first complex molecules. Out of fire came water vapor, out of chaos came the seeds of calm. The atmosphere thickened with carbon dioxide, trapping heat, slowing the planet's cooling, and eventually creating a pressure strong enough to allow rain. Every drop of water that would someday fall had to first be born from steam rising out of the fire. Over millions of years, as the collisions slowed and the surface cooled, the red sky began to darken. The molten glow dimmed, the air grew heavier, and the temperature dropped enough for clouds to condense. It must have been an astonishing transition, the first rainfall in history, descending through an atmosphere still filled with smoke and lightning. The raindrops hissed as they struck the molten rock, evaporating instantly, but they did not stop. They fell endlessly, for thousands of years, until at last the crust cooled enough for the water to remain. From the sky of fire came the first oceans. In that transformation lies one of the universe's quietest miracles, that from burning stone and poisonous gases could emerge something so gentle as rain. The sky, once made of flame, became the cradle of water. The same heat that once devoured everything now gave way to clouds, to condensation, to balance. The Earth's fever became its calm. And when the first light of a blue dawn reflected off those new oceans, the planet took its first deep breath of peace. Even now, traces of that fiery origin remain. Every volcanic eruption is a reminder of the world's molten heart still beating below. Every lightning storm echoes those ancient electrical surges that sparked chemistry into motion. The sky we see today, blue, calm, breathable, is only a cooled version of that earlier fire. Its oxygen, its clarity, its softness were all born from that age of heat and chaos. We live beneath the gentler face of a sky that once burned with creation's raw energy. If one could listen to that ancient world, its voice would be a slow roar, the hiss of vapor, the thunder of eruptions, the rhythm of a planet forging its identity through fire. And yet, beneath the violence, there was always purpose. The Earth was not being destroyed, it was becoming. Its molten rivers were arteries, its eruptions were breaths, its storms were thoughts forming in the furnace of existence. The sky of fire was the first mind of the planet, dreaming not in consciousness, but in chemistry. So when we look up today, into the tranquil blue dome above us, we are looking into a history of flame. Every molecule of air has passed through that transformation, every drop of water once danced as vapor in that infernal sky. The blue we now call peaceful is simply the cooling of ancient light, the memory of fire made calm. The world we know, the forests, the clouds, the soft twilight over the sea, is the echo of a time when the sky itself was molten and the planet burned its way into being. And perhaps there is comfort in that. For if a world born in fire can one day cradle life so tenderly, then all creation, no matter how violent its beginning, carries within it the possibility of peace. The sky that was once made of flame now shelters us in its cool blue breath, a reminder that even chaos, when patient enough, becomes beauty. Before there were oceans as we know them, there were no rivers, no lakes, no seas reflecting the sky. There was only vapor and fire, a planet whose surface boiled relentlessly, where water could not settle, and yet where the seeds of it already existed. Hydrogen and oxygen, two elements destined to dance together as life-giving water, drifted in the atmosphere, fragmented, volatile, waiting for the right moment to combine. It was a world pregnant with possibility, but not yet alive. The oceans that would cradle life had not yet fallen. They were only dreams condensed in the chemical imagination of the young planet. Scientists believe that much of the water on Earth arrived from the cosmos itself. Ancient comets and asteroids, icy bodies formed far from the sun, collided with the young Earth, delivering fragile parcels of hydrogen and oxygen. Each impact was violent, vaporizing much of what it brought, yet a fraction survived. Slowly, over millions of years, these droplets of cosmic memory accumulated. Every raindrop, every glacial ice crystal, every ocean wave carries with it the signature of a star's long-dead embrace and the frozen remnants of distant worlds. Our oceans, in a way, are borrowed from the universe, a gift delivered across the dark. Before water could rest on the planet's surface, there was a delicate negotiation between heat and gravity. The Earth's skin was still hot enough to vaporize moisture on contact, creating immense clouds of steam that rose and fell in eternal cycles. Lightning streaked through this dense vapor, igniting chemical reactions that forged more complex molecules. The first water was not gentle or calm. It was explosive, electric, and alive with transformation. The oceans, when they finally formed, were the distilled product of this tumultuous prehistory, a reconciliation between chaos and gravity. The notion of an ocean before water is, in some ways, a meditation on absence as much as presence. The planet carried the memory of liquid long before it could manifest, a yearning in the minerals and gases that anticipated rain and seas. Magma oceans cooled unevenly, creating basins where water could eventually pool. The first puddles were shallow, fleeting, constantly evaporating, yet they were the precursors of permanence. These tiny, ephemeral reservoirs were the first experiments of a planet learning how to hold its own life. There is a profound poetry in the idea that water, the substance so essential to life, was not originally of this earth. It came as a traveler, hitching a ride on icy fragments from the outer solar system, carrying with it the possibility of oceans, of rivers, of life. Each comet that struck left behind more than just water. It left a chemical fingerprint, a whisper of the broader cosmos embedded in the fabric of the planet. Our seas are, in a sense, letters written by distant worlds, arriving billions of years late to their final address. Even before the oceans stabilized, Earth's surface was alive with chemical potential. The atmosphere, rich in carbon dioxide and nitrogen, mixed with hydrogen from the impacting comets to form the first primitive compounds of life. Amino acids, the building blocks of proteins, may have formed spontaneously in this fiery, watery crucible. The line between geochemistry and biology blurred. Every eruption, every rainfall, every flash of lightning carried within it the potential for life. The first oceans were not mere bodies of water. They were laboratories, rehearsals for existence itself. The ocean before water, then, is more than a metaphor. It is a state of becoming. The planet itself was experimenting, learning how to balance heat, gravity, and chemistry. Basaltic plains absorbed some water, while steam-laden atmospheres carried others away. Some water-dissolved minerals, enriching the young crust. Some seeped into the mantle, trapped in the folds of mineral lattices, destined to return millions of years later through volcanic release. Earth was not yet a home for life, but it was learning how to become one. As time passed, the first true oceans began to settle into place. Rainfall, once almost unending, finally filled basins and valleys. Vapor condensed into liquid, and the seas slowly spread, covering much of the planet's surface. They were dark, acidic, rich with dissolved minerals, and yet they were perfectly suited to hold the first fragile sparks of biology. These primordial oceans, born from chaos and cosmic inheritance, would become the cradle of life, the world's first memory of itself. It is humbling to consider that every ocean wave today carries within it fragments of that ancient history. Hydrogen atoms may have arrived from a comet billions of years ago. Oxygen atoms may have originated in the hearts of long-dead stars. Every drop is an archive, every current a river of memory stretching across time. The water that nourishes life now was once part of a journey far older than the Earth, traveling across space, surviving collisions, and finally finding rest on a planet that had been waiting for it. Before water, there was anticipation. Before life, there was potential. The oceans that now calm our skies and reflect our clouds were forged in fire and dust, hammered into existence by impact and gravity, enriched by the chemistry of lightning and cosmic delivery. They are the proof that from chaos, through patience and persistence, the impossible becomes tangible. Every wave is a whisper of a prehistory that we cannot see but can sense, a reminder that Earth's capacity for life is older than life itself. In this way, The Ocean Before Water is a meditation on the hidden journeys of the planet. It teaches us patience, endurance, and the quiet power of accumulation. The first oceans were not quiet, they were violent, dynamic, transformative. Yet through that violence came the possibility of calm, of reflection, of life. Today, when we stand by the sea, listening to the gentle lap of waves, we are witnessing the culmination of billions of years of cosmic travel, chemical alchemy, and planetary learning. The calm surface hides the memory of fire, dust, and distant comets. And so, to imagine the ocean before water is to imagine the planet itself dreaming, preparing, shaping, and learning how to hold life. It is a reminder that even the gentlest landscapes of the present were born from chaos and collision, that what seems stable is layered with history, and that every molecule of water in our bodies has journeyed through the stars and comets before finding its place here. The Earth has always carried memory in its veins, and the ocean is its oldest, quietest testament to the persistence of possibility. Long before humans set foot upon the Earth, before animals roamed forests or oceans teemed with life, continents themselves were born, shifted, and vanished in a slow, majestic rhythm. The planet's surface was not fixed, but alive with motion, a breathing mosaic of land and water. Supercontinents formed and broke apart, each a fleeting expression of the Earth's restless energy, each a silent testament to cycles so vast that they dwarf human imagination. These were the hidden continents, the deep architecture of the planet, rising and falling over billions of years, carrying the memory of worlds that once were. Imagine Rodinia, a supercontinent assembled over 1 billion years ago. Its vast lands stretched across much of the planet, uniting crustal fragments that had once drifted independently. Mountains pushed upward where plates collided, and shallow seas formed where land sank. Rodinia was alive in a geological sense. Molten rock churned below, heat pulsed through its crust, and the air above it carried the faint whispers of volcanic activity. And yet, despite its grandeur, it would not last. Tectonic forces, slow but relentless, began to tear it apart. Oceans crept between fragments, slowly dissolving the unity of land into pieces, fragments that would drift for eons. Before Rodinia, there was Pannotia, and before that, other arrangements we can scarcely name. Each supercontinent left its trace, even after it disappeared beneath the mantle or was scattered into smaller landmasses. These lost continents are like dreams buried under consciousness. They no longer exist as they once did, yet their influence remains, shaping the Earth's surface and interior. The crust itself remembers the stress, the pressure, the collisions of these vanished lands. Mountains, now eroded to gentle hills, were once towering ranges marking the boundaries of ancient plates. Sedimentary rocks formed in seas that no longer exist. Their fossils tell stories of ecosystems long extinguished. The process of continental assembly and dispersal is both violent and graceful. Plates collide in slow-motion chaos, forcing rock upward in mountain chains that scrape the sky. Other plates subduct, sliding beneath neighbors, melting into the mantle, only to return later as volcanic eruptions. The Earth's crust is recycled in cycles that span hundreds of millions of years. Each continent, as it moves, carries with it a fragment of the past, minerals forged in previous eras, isotopes marking earlier collisions, sediments recording vanished climates. In this sense, continents are archives. They store memory in stone, keeping the story of the planet alive across time. The lost continents beneath us are not entirely gone. Zealandia, once a supercontinent in its own right, now lies mostly underwater, hidden beneath the waves, a ghost continent that quietly influences ocean currents and geological formations. Greater Adria, once part of Pangaea's southern assembly, was subducted beneath Europe, leaving behind remnants in the Alps and the Apennines. These hidden continents are the palimpsests of Earth, overwritten by new landmasses yet still present in subtle form. They remind us that the Earth we see today is merely the latest iteration, a temporary arrangement in an ongoing cycle. Mountains, too, are memory. Even the highest peaks we see today, the Himalayas, the Andes, carry the scars of ancient collisions. Their rocks were once sediment on the ocean floor, compacted and folded as plates converged. Fossils of marine life can be found high above sea level, silent witnesses to a time when those rocks lay beneath water, in the deep, calm seas of a vanished world. The very structure of continents records the rhythms of assembly and dispersal, like the slow breathing of a planet learning balance through movement. The concept of lost continents forces us to reconsider permanence. We often see land as stable, as unchanging, yet the planet operates on a scale far beyond human perception. Continents are ephemeral, shifting, dissolving, and reforming over billions of years. Their lifespans dwarf ours, and yet each carries within it the blueprint for the next. The Earth is both gardener and archivist, cultivating land, dissolving it, and preserving memory in stone, mineral, and sediment. It is remarkable to think that the continents we inhabit are composed in part of fragments of older continents. The rocks beneath our feet may have traveled thousands of kilometers, carried by tectonic drift from ancient oceans to new mountains. Each plate boundary, each fault line, is a seam in this vast quilt of memory. The land itself is stitched together from the pieces of what came before, and in this way, we walk daily upon the ghosts of vanished continents. Even the soil we touch, the sands of beaches and deserts, have origins tracing back to these ancient supercontinents. Minerals eroded from mountains that existed billions of years ago now lie in riverbeds and dunes, carried slowly by wind and water across eons. In every handful of earth, there is a story of collision, uplift, and erosion, a story of continents born, drifting, and dying only to be reborn again in new forms. In contemplating the hidden continents, we are invited to reflect on time itself. Human history is brief, but geological history is patient, vast, and recurring. Continents are the slow heartbeat of the planet, pulsing through cycles of creation and destruction, teaching us that stability is temporary, yet memory endures. Each mountain, each valley, each buried craton holds the echo of a world that existed long before the Earth we know. The age of hidden continents is a meditation on impermanence and continuity. While supercontinents rise and fall, the Earth maintains its internal rhythm, the mantle's slow convection, the core's molten churn, the tectonic dance that never ceases. These forces shape not only the land but the possibilities for life itself. By understanding the hidden continents, we glimpse the deep time processes that made our world habitable and discover that the Earth is more alive and more enduring than it appears. Even now, as we travel across plains, mountains, and plateaus, we are following paths laid down by lands that no longer exist in their original form. We are walking on the sedimentary memory of vanished continents, tracing the slow, deliberate patterns of a planet in constant motion. The Earth carries its history silently, beneath every footstep, beneath every ocean, beneath every sky. And in its patient movements, it reminds us that the world we see is only a single arrangement, a fleeting chapter in a story billions of years long. Beneath the mountains, beyond the plains, below the oceans that now shimmer under the sun, there lies another memory of Earth, one older than continents, older than oceans, older even than the first molten crust. It is the memory written in stone, in minerals, in isotopes that trace the very birth of the planet. Every atom carries a story, a fragment of a world that existed before the Earth we know. These are the echoes of proto-Earth, the whispered signatures of a planet learning to exist in the void, long before life or air or water could claim dominion. The early Earth was not silent. Its voice was carried in heat, in the grinding of rocks, in the vibrations of collisions that shaped the young world. The first crust was thin, fragile, and constantly broken apart by impacts from asteroids and comets. Yet even in its instability, there was structure. Minerals crystallized in the molten rock, forming the first patterns of order from chaos. Zircon crystals, tiny and resilient, are among the oldest known survivors of this era. They have endured for more than 4 billion years, holding within them chemical clues that speak of the conditions on a world long vanished. In each crystal is recorded the temperature, the water, the pressure of that ancient Earth, a memory written in solid form. Before the familiar continents, before the oceans filled the basins, before the sky could hold clouds, Protocontinents rose and fell like tides of stone. They were small, scattered, and temporary, but they were the first attempts at land, islands of stability in a world otherwise molten and chaotic. These fragments collided, fused, and broke apart in a slow dance dictated by the planet's heat and gravity. The rocks formed then are still with us, hidden beneath younger layers, relics of a time when the Earth was learning the rhythm of balance. The chemical composition of these ancient rocks tells a story older than imagination. They are enriched with elements formed in stars long before the Sun existed, atoms that traveled through space across billions of years before coalescing into the Earth. Iron, silicon, magnesium, oxygen, they were once part of other worlds, now reborn in our own. The planet itself is a palimpsest, layers of memory stacked upon one another, rewritten with each new formation, yet never entirely erasing what came before. Protocontinents were not stable. Their edges were constantly broken by impacts and molten currents. Volcanoes erupted endlessly, and lava oceans stretched across the landscape, reshaping the surface in waves of fire. Yet these eruptions were not only destructive, they were creative. They forged new minerals, created gradients in chemistry, and laid the foundations for future life. Each collision, each eruption, was a formative lesson in persistence and adaptation. The Earth was learning to survive itself, and in that learning, it preserved memory. Even the mantle, far below the thin crust, retains whispers of the proto-Earth. Seismic studies reveal heterogeneities, dense regions, cold slabs, and ancient rock fragments that hint at a world older than the one visible from above. These deep relics, buried kilometers below the surface, have witnessed the formation of oceans, the rise of mountains, and the dance of continents. They are the planet's archives, untouched by the weathering of time above, silent yet eloquent in their persistence. One of the most fascinating aspects of proto-Earth is its capacity for recycling. Rocks that formed billions of years ago were often subducted into the mantle, where heat and pressure altered them, only for them to rise again in volcanic eruptions or through tectonic uplift. In this way, the planet constantly reshapes itself while preserving memory. Every layer, every mineral, every isotope is a record of transformation, a fragment of a world that existed before the Earth we inhabit today. Even water, which would eventually form oceans, carries echoes of this early time. Hydrogen in ancient rocks may have originated from the solar nebula or from cometary impacts, tracing a lineage older than the planet itself. These atoms, now part of rivers, lakes, and seas, have been recycled countless times, moving through rocks and minerals, before finally settling into stable reservoirs. The Earth's earliest oceans were born from both cosmic inheritance and internal chemistry, carrying the memory of a fiery, molten past. It is humbling to realize that the Earth we see is only the latest incarnation of countless earlier forms. Each protocontinent, each molten ocean, each layer of volcanic rock contributes to a memory preserved in stone. Mountains we now climb, valleys we explore, and soils beneath our feet are all descendants of these ancient formations. To touch a rock is to touch a fragment of a world that existed before our own, a shard of memory older than imagination. The echoes of proto-Earth remind us that time is not linear, but layered. Past, present, and future coexist in the very structure of the planet. Rocks carry the history of collapse and creation, of fire and cooling, of chaos gradually forming order. They are not merely inert objects but living archives, a geological consciousness that persists through eons. By studying them, we read the memoirs of a planet that remembers its own formation, its own trials, and its own persistence. Even today, remnants of protocontinents are preserved in cratons, the stable cores of modern continents. These ancient fragments are like fossils of the Earth itself, surviving billions of years of tectonic upheaval. They are the last witnesses to a time when the world was young, volatile, and untamed. To walk upon them is to walk upon history itself, to be reminded that the Earth's memory runs far deeper than surface appearances suggest. In the memory of proto-Earth, there is a lesson in resilience. The planet endured collisions, fire, and the constant reshaping of its surface, yet it continued to exist, to evolve, to preserve traces of what had come before. Life itself, when it finally emerged, did so upon a stage built from this endurance. The rocks beneath us are more than stone. They are the living record of Earth's earliest chapters, the silent testament to a planet that existed long before the one we know. And so, when we contemplate the proto-Earth, we contemplate continuity itself. We see a world that remembers, that persists, that transforms while preserving its own history. The Earth that existed before the Earth we know was not gone. It is here still, woven into every mineral, every rock, and every molecule beneath our feet. The memory of that ancient world flows through the planet like a quiet river, shaping what we see, what we know, and what we are yet to discover. The first atmosphere of Earth was unlike anything we breathe today. It was not a gentle blend of nitrogen and oxygen, but a thick, oppressive shroud of carbon dioxide, methane, ammonia, and water vapor. The sky glowed with a faint red hue, illuminated not only by the young sun but by the endless flashes of lightning that ignited chemical reactions across the planet. It was a furnace of potential, a volatile mixture that carried the seeds of everything to come, yet it was inhospitable, unrecognizable, and alive in its own elemental way. This was the breath of a world still learning how to exist. As the planet cooled and the first crust stabilized, gases released by volcanic activity began to accumulate in the atmosphere. Steam, carbon dioxide, sulfur compounds, and nitrogen swirled endlessly, creating a dense, opaque layer above the Earth's surface. Cometary impacts added more water vapor, while the chemical reactions in the atmosphere generated molecules never before seen. In this primordial air, there were no birds, no clouds, no blue sky, only the raw, dynamic processes of planetary chemistry at work. The atmosphere itself was a laboratory, an alchemist that would eventually forge the first ingredients for life. Lightning played a pivotal role in this early stage. Endless storms arced across the sky, sending currents of electricity through the thick gases. These surges of energy transformed simple molecules into more complex compounds, amino acids and nucleotides, the building blocks of proteins and genetic material. The first atmosphere, though hostile, was fertile in ways invisible to the eye. It carried within it the memory of stars, the inheritance of cosmic chemistry, and the raw potential for life to emerge. Every spark in that stormy sky was a rehearsal for the miracle of creation. The atmosphere, though thick and volatile, began to interact with the surface in subtle ways. Rainfall, initially scalding and acidic, carved channels into the cooling crust. Steam condensed into droplets, which struck the molten or semi-solid rocks, creating chemical reactions that enriched the surface with minerals. This interaction between air and stone was the planet's first attempt at balance, a delicate negotiation that would eventually allow oceans to persist and life to emerge. The atmosphere was not merely a blanket of gas. It was a participant in the shaping of the world, an active agent in the Earth's memory and evolution. Early scientists, looking at isotopic evidence in rocks, have pieced together glimpses of this atmosphere. Noble gases trapped in zircon crystals, ratios of carbon and nitrogen, traces of sulfur and hydrogen, all these elements tell a story of a sky in flux. It was not static. It changed over millions of years as volcanic outgassing, cometary impacts, and chemical reactions continually reshaped it. The atmosphere recorded the planet's growth, its crises, and its transformations, preserving a memory older than any living organism. Without this thick, turbulent atmosphere, Earth could not have cooled properly. It acted as both furnace and shield, trapping heat when necessary, releasing it when possible. The first atmosphere also provided the foundation for the planet's magnetic field to interact with charged particles from the sun. These interactions protected the surface from the worst of solar winds and helped to retain volatile compounds. In this way, the atmosphere was both sculptor and guardian, maintaining conditions that allowed Earth to gradually move from a fiery, uninhabitable world toward one capable of nurturing life. Even before oxygen appeared in abundance, the atmosphere carried the memory of life yet to come. It was rich with nitrogen and carbon compounds, forming a chemical palette from which biochemistry could eventually paint its first strokes. The clouds and storms, the lightning and acid rain, were not merely destructive, they were creative. They transformed simple molecules into complex ones, drove cycles of dissolution and deposition, and prepared the surface for the oceans that would eventually stabilize. This atmosphere was a teacher, instructing the young planet in patience, resilience, and preparation. The weight of the first atmosphere must have been enormous, pressing down on the fragile crust below. It shaped the behavior of water, influencing how it condensed, evaporated, and eventually fell as rain. It influenced wind patterns, which carried dust and minerals across the young world. It even influenced temperature gradients, creating pockets of stability in which the first organic molecules could persist. Though invisible to the human eye, this primordial atmosphere was a living framework, a dynamic system preserving the memory of the planet's early trials and triumphs. One of the most remarkable aspects of this early air is its connection to the cosmos. Hydrogen, oxygen, carbon, and nitrogen were all forged in stars long before the Earth existed. The atmosphere was a reservoir for this stardust, holding within it the memory of events far beyond the solar system. Every molecule was a traveler from distant galaxies, a fragment of other worlds that had collapsed, exploded, and reborn. The air of early Earth was not merely local, it was universal, carrying cosmic memory across the void and embedding it in the young planet. Over millions of years, as volcanic activity slowed and the planet cooled further, this first atmosphere gradually transformed. Water vapor condensed into the first oceans, carbon dioxide was partially absorbed by the crust, and nitrogen became more dominant. Yet, even as it changed, the atmosphere retained memory of its origins. The storms, the lightning, the chemical reactions, all left signatures in rock, mineral, and isotope that scientists can still read today. These invisible traces are a testament to a time when Earth was learning how to hold a sky, how to sustain air, and how to prepare for the fragile miracle of life. To imagine this early atmosphere is to imagine a world alive with invisible processes, a sky that is simultaneously destroyer and creator. It was a place of extremes, heat, pressure, lightning, and acid rain, but it was also a place of potential, where the first whispers of biology were waiting to emerge. It reminds us that life does not appear in calm, gentle environments alone, but often in spaces of turbulence, pressure, and transformation. The atmosphere was a crucible, and from its fires, everything that would later walk, swim, and breathe on Earth would eventually emerge. Even now, the atmosphere carries traces of that past. Isotopic ratios in nitrogen, argon, and carbon dioxide are fingerprints of its volatile youth. Volcanoes continue to release gases that mirror the processes of the past. Lightning storms echo the chemical creativity that once shaped the first organic compounds. Clouds, wind, and weather are ongoing reminders that Earth's sky has memory, that even invisible air carries the weight of billions of years of history, preserving the story of a planet learning to breathe, to nurture, and to remember itself. The first life on Earth was not a sudden event, but a quiet awakening in the depths of those ancient oceans. It emerged in the folds of chemistry and geology, where water, minerals, and energy converged in just the right balance. These earliest organisms were microscopic, simple, fragile, but they were also the first conscious agents of the planet's memory, carriers of a continuity that stretched back to the formation of molten rock, the delivery of water from the cosmos, and the shaping of continents. Life began not as a single spark, but as a slow crescendo of molecular experimentation. For millions of years, chemical reactions in the oceans created amino acids, nucleotides, and other building blocks of biology. They were subjected to cycles of heating, cooling, drying, and rehydration, particularly near hydrothermal vents and tidal pools. Each cycle tested these molecules, selecting combinations that could persist, that could fold into structures capable of replicating themselves. The oceans were not only a home, they were a crucible of trial and error, a laboratory without walls, vast and relentless, where the chemistry of life rehearsed its first movements. The first cells were simple membranes enclosing genetic material and metabolic enzymes. They were not complex, but they were resilient, capable of harnessing chemical energy from their environment. Some drew energy from minerals seeping from the ocean floor, others from sunlight penetrating shallow waters. These early life forms were silent architects of the future, creating gradients, consuming molecules, and in subtle ways transforming the chemistry of the oceans around them. Each generation carried the memory of the environment within it, a living record of conditions, adaptations, and successes that would echo through time. Life's emergence was intimately tied to the planet's previous history. The protocontinents provided minerals, the atmosphere provided chemical precursors, the oceans provided stability and motion, and lightning supplied energy. Each element of the pre-Earth world contributed to the first fragile cells. The story of life is inseparable from the story of the planet itself. Chemistry and geology converge to create biology. In this sense, the first organisms were not separate from the Earth. They were expressions of the planet learning to know itself through living processes. Early life existed in a harsh, volatile world. Temperatures fluctuated, ultraviolet radiation rained down from the sun, and chemical gradients shifted unpredictably. Yet in this instability, life persisted. It adapted. It discovered ways to harness energy, to repair damage, to replicate despite chaos. Each cell was a memory carrier, a vessel of experience encoded in DNA or RNA-like molecules. By surviving, reproducing, and passing on information, these microscopic organisms became the first storytellers of Earth's long history, inscribing the memory of the environment into the lineage of life. As these early organisms proliferated, they began to influence the planet in profound ways. Photosynthetic microbes, for example, captured sunlight and converted it into chemical energy, releasing oxygen as a byproduct. Though initially toxic to most existing life, this oxygen began to accumulate in the atmosphere over hundreds of millions of years, transforming the planet's chemistry and paving the way for new forms of life. Life was no longer merely a product of Earth. It had become a co-creator, shaping its own environment and rewriting the conditions for future generations. The first life also introduced cycles of energy, of carbon, of nitrogen that would persist to this day. Microbes metabolized compounds, created waste products, and influenced mineral deposition. They turned chemical gradients into patterns, randomness into order, chaos into rhythm. These cycles established a feedback loop between the planet and its inhabitants, a dynamic memory system in which Earth and life co-evolved. Even in their simplicity, early cells were the first participants in a conversation that would continue across billions of years. It is awe-inspiring to consider the fragility and resilience of this first life. These organisms existed without consciousness, without awareness, yet they carried the capacity to endure across unimaginable spans of time. They were proof that life need not be complex to be meaningful, that persistence itself is a form of legacy. Every molecule replicated, every metabolic pathway maintained, every cell survived against the odds is a testament to the quiet, patient intelligence of evolution, the planet itself learning through the medium of living chemistry. Life, once established, became a vessel of planetary memory. Genetic material encoded not just survival instructions, but traces of the environment, the chemical history of oceans, the legacy of rocks and minerals, the echoes of cosmic delivery. DNA and RNA became the threads that wove together the history of Earth and the story of life, preserving it in forms capable of enduring for billions of years. The first organisms were custodians of memory, recording in their molecules the long prehistory of the Earth. Even in their microscopic simplicity, these first life forms were revolutionary. They transformed oceans, influenced the atmosphere, and began the slow, iterative process of adaptation that would ultimately produce the diversity of life we see today. They remind us that life is not an isolated phenomenon. It is a continuation, a memory, a reflection of the planet's past. Every living organism carries echoes of those first cells, the first fragile attempts at persistence in a volatile, young world. The emergence of life is the bridge between pre-life chemistry and the biological world. It represents the moment when memory, previously stored in rock, water, and atmosphere, became encoded in living matter. Life is Earth reflecting upon itself, a conscious record written in molecules, a continuation of the planet's story in a new medium. The first organisms were tiny, invisible, and unassuming, yet they held within them the beginnings of all future life, the first echoes of the Earth we now know. The evolution of life over the next billions of years was a slow, patient unfolding, a meditation written in cells and molecules, oceans and rocks. The earliest microbes, simple and fragile, laid the foundations for complexity, creating cycles of energy, nutrients, and chemical balance that would ripple outward through the environment. Life began to interact with the planet in ways that were both subtle and profound, altering atmospheric composition, reshaping ocean chemistry, and laying the groundwork for the diverse forms that would later emerge. Each organism, though microscopic, was a participant in a grand experiment that spanned the globe and spanned eons. Photosynthetic bacteria, appearing around 3 billion years ago, were the first major agents of planetary transformation. By capturing sunlight and converting it into chemical energy, they began to release oxygen as a byproduct, a substance toxic to most life at the time, yet essential for the emergence of new possibilities. This oxygen slowly accumulated in the oceans and atmosphere, a quiet revolution that would eventually pave the way for multicellular organisms. These microbes were the planet's first engineers, shaping conditions for life long before complex beings could exist. Their tiny actions echo across time, a testament to the power of persistence, adaptation, and collective influence. The oceans, still ancient and turbulent, were now rich with chemical gradients and life forms responding to them. Microbes formed mats and colonies, interacting with minerals, sunlight, and currents. They created localized ecosystems in hydrothermal vents, shallow tidal pools, and beneath icy layers, each a miniature theater of chemical experimentation. Life, still invisible to the human eye, was actively rewriting its environment. These microbial communities introduced stability to chemical fluxes, recycled nutrients, and created conditions in which more complex structures could emerge. In their quiet persistence, they were both witnesses to and authors of Earth's evolving memory. At the same time, the Earth's surface continued its restless motion. Tectonic activity shaped mountains and basins, influencing the distribution of oceans, creating habitats, and redistributing minerals. Volcanic eruptions, once hostile, now delivered nutrients to the oceans, feeding the microbial communities that had become increasingly sophisticated in their interactions with the environment. Life and geology were entwined. Each eruption, each plate movement, each storm, each chemical reaction was part of a conversation that spanned billions of years, a dialogue between the living and non-living components of the planet. The accumulation of oxygen, known as the Great Oxidation Event, fundamentally altered the trajectory of life. It transformed the oceans, precipitating iron formations and changing the chemical balance. Oxygen began to saturate the atmosphere, creating a protective layer that would eventually shield life from harmful ultraviolet radiation. The first eukaryotic cells, organisms with nuclei and complex internal structures, emerged during this period, representing a profound leap in biological organization. Life was no longer solely microbial and uniform. It had begun to diversify, experimenting with size, complexity, and cellular cooperation. This period also marked the first extinction events, though subtle compared to the cataclysms of later eras. Changes in chemical composition, climate fluctuations, and oxygen toxicity eliminated organisms that could not adapt, creating space for new forms. Extinction and survival became part of the ongoing memory of life, a natural filtering process that preserved adaptability and innovation. Through these processes, the planet was refining its biological record, maintaining continuity while allowing for transformation. By the time multicellular life appeared, life had already learned persistence. Cells had evolved cooperation, specialization, and communication, laying the groundwork for complex tissues and structures. Simple colonies of cells gradually became differentiated, creating organisms capable of movement, predation, and environmental modification. The first multicellular organisms were soft-bodied, fragile, and constrained by the limitations of diffusion, yet they were the harbingers of the vast diversity that would soon flood the planet. These pioneers carried within them the accumulated memory of billions of years of microbial existence, encoded in their molecules and behaviors. The Cambrian explosion, around 540 million years ago, represents one of the most extraordinary chapters in this history. In a relatively brief geological span, life diversified into a multitude of forms, creatures with shells, spines, limbs, and complex sensory organs. Oceans became theaters of experimentation, populated by an array of predators, grazers, and filter feeders. Evolution accelerated, driven by competition, environmental pressures, and opportunities created by prior generations. The planet was now not only sustaining life, it was a dynamic canvas upon which life expressed itself in increasingly intricate and imaginative ways. Land, once barren, began to be colonized by life as well. Plants moved from shallow waters to moist soils, creating the first terrestrial ecosystems. They anchored soil, captured sunlight, and began producing oxygen in significant quantities. Arthropods and other animals soon followed, exploring the new niches offered by terrestrial environments. Life was no longer confined to the oceans, it was expanding its domain, reshaping the planet in both obvious and subtle ways. Each new adaptation was an iteration of the memory carried from the earliest microbial experiments, a continuation of processes that had begun in the oceans billions of years earlier. By the time vertebrates appeared, life had acquired the tools for complexity, nervous systems, muscles, and behaviors that allowed organisms to interact actively with their surroundings. Ecosystems became increasingly intricate, interdependent, and resilient. Extinction events, climate fluctuations, and geological shifts continued to test life, but each challenge strengthened the evolutionary memory, preserving the lessons of survival and adaptation. Life and Earth had entered a feedback loop. Organisms shaped the environment, and the environment shaped organisms, both carrying the memory of countless generations in their structures, behaviors, and genes. Even now, we can trace echoes of these processes in the genetic and physiological memory of modern organisms. The proteins, enzymes, and metabolic pathways of today's life forms are the descendants of those first chemical experiments in the oceans. The oceans themselves, the continents, the atmosphere, all retain traces of these ancient interactions. Life is not separate from the planet's memory, it is a continuation of it, a conscious thread woven into the fabric of Earth's history. The evolution of life is, ultimately, a meditation on persistence, adaptation, and interconnection. It reminds us that even the smallest organisms can reshape the planet, that complexity emerges from simplicity, and that the memory of Earth is carried not only in rock and water but in the living cells that have inherited and preserved it. Life is the planet reflecting upon itself, recording its history, and preparing for the chapters yet to come. The rise of complex ecosystems was not sudden, but a slow weaving of life into the fabric of the planet, a symphony of interdependent species that carried with them the memory of billions of years of evolution. Oceans teemed with life forms that interacted in subtle, intricate ways: predators and prey, filter feeders and algae, plankton drifting in currents while larger creatures roamed above. Each organism was both participant and observer, responding to environmental shifts, chemical changes, and geological upheavals. Life was no longer merely surviving, it was beginning to shape the world around it, leaving traces that would persist long after individual species disappeared. Forests and swamps began to emerge on land, their roots stabilizing soil and their leaves capturing sunlight to fuel photosynthesis. These pioneering plants transformed the atmosphere, increasing oxygen levels and enabling the proliferation of larger, more active organisms. Insects, small and abundant, explored this new terrain, pollinating plants, consuming organic matter, and establishing the first complex food webs. The planet's memory was being carried forward not only in rocks and water but in the biological networks forming above and below the surface. Every leaf, every burrow, every microbial colony contributed to a vast, living archive. Coral reefs, appearing in shallow oceans, became living libraries of biodiversity. They recorded environmental changes in their growth patterns, incorporating minerals from seawater and providing habitats for countless species. Reef ecosystems were laboratories of adaptation, fostering cooperation, competition, and specialization. Each organism that lived and died within them added to the memory of the oceans, leaving chemical and structural traces that could survive for millions of years. These early reefs were more than habitats. They were chronicles, preserving evidence of evolutionary innovation and ecological balance. Predation became a driving force, shaping anatomy, behavior, and survival strategies. Eyes evolved, spines emerged, shells hardened. The interactions between organisms created feedback loops, where adaptations in one species spurred responses in another. Life's memory was no longer passive. It was encoded in behavior, morphology, and survival strategies. The record of evolutionary trials and errors became embedded in genomes, proteins, and metabolic pathways, transmitting knowledge across generations. The Earth itself became a participant in this process, as geological and climatic shifts interacted with biological innovations to create new opportunities and challenges. Mass extinctions, though devastating, were integral to the preservation and transformation of Earth's memory. Events like the Permian-Triassic and later extinctions erased dominant species, but they also created space for new life forms to emerge, diversify, and adapt. Extinction is both a punctuation and a lesson. It preserves resilience and encourages innovation. The planet's archive is written not only in survival but also in disappearance. Fossil records, chemical traces, and isotopic markers retain evidence of life lost, creating a ledger of ecological memory that scientists can still interpret today. The carbon cycle became increasingly complex as life expanded onto land. Plants drew carbon dioxide from the atmosphere, storing it in tissues, while microbes decomposed organic matter, releasing it back into the soil and air. These cycles stabilized the climate, regulated atmospheric composition, and provided the conditions necessary for further biological innovation. The Earth and its inhabitants co-evolved. The planet's memory shaped life, and life, in turn, reinforced the planet's memory through chemical and physical processes. This interdependence became the defining feature of the biosphere. The oceans, too, evolved alongside terrestrial ecosystems. Phytoplankton proliferated, producing oxygen and serving as the base of intricate food webs. Marine animals diversified, developing specialized feeding strategies, mobility, and communication. Nutrients cycled between the deep sea and surface waters, creating dynamic environments in which life could thrive. Currents and tides carried chemical and biological signals across vast distances, linking ecosystems in ways that preserved information and enabled adaptation. Life was writing its own history, not in words, but in interactions, chemistry, and form. By the Devonian period, life had established complex relationships with its environment. Fish diversified, forests expanded, and soils deepened. The Earth had become a living system, with feedback loops connecting biology, chemistry, and geology. Each species carried within it the memory of previous generations and the environmental history of the planet. Life was no longer simply a reaction to conditions. It had become an agent of change, shaping temperature, oxygen levels, and nutrient availability. Earth and life were now inseparable, co-authors of a long, ongoing story. Even microscopic organisms played crucial roles in ecosystem memory. Microbes cycled nutrients, decomposed dead matter, and facilitated the survival of higher organisms. Symbiotic relationships emerged, from fungi and plant roots to microbial communities in the guts of animals. Cooperation, rather than just competition, became a tool for persistence and adaptation. In this way, Earth's memory was encoded not only in the physical environment but also in the networks of living relationships that persisted across time. The rise of complex ecosystems teaches us about interconnection and patience. Each layer of soil, each strand of DNA, each reef structure, and each ancient forest holds evidence of cumulative adaptation. Life's memory is both collective and individual, shared across networks of organisms and recorded in the planet itself. Evolution is a slow conversation between the living and the non-living, between organism and environment, carried forward in cycles of creation, destruction, and adaptation. By studying these ancient ecosystems, we glimpse the resilience and intelligence of Earth's memory. The patterns of life, extinction, and rebirth demonstrate that survival is not merely a function of strength, but of flexibility, cooperation, and timing. The planet itself orchestrates these processes, creating conditions that preserve memory, encourage diversity, and sustain life over immense spans of time. These ancient networks, both visible and invisible, are the blueprint for all that would follow, including the emergence of human consciousness and civilization. The complexity of early ecosystems is a meditation on continuity and transformation. Life's memory is written not only in genes but in interactions, chemical cycles, and geological traces. Every organism, from the smallest microbe to the largest predator, contributes to a record that spans millions of years. In understanding this, we recognize that the Earth we inhabit is the product of countless iterations, adaptations, and lessons preserved through the interplay of life and environment. The spread of life across the continents marked a profound transformation in the memory of Earth. Plants, having first colonized the damp soils of the Devonian, now diversified into vast forests that would alter the planet's atmosphere and climate. Their roots stabilized soil, capturing nutrients and water, while leaves captured sunlight to produce oxygen. This surge of photosynthetic activity increased atmospheric oxygen levels, fundamentally reshaping the conditions for future life. Forests were not simply passive landscapes. They were living archives, recording environmental changes and influencing the very chemistry of the Earth itself. Insects and arthropods, the first aerial explorers, navigated this new arboreal world. Their flight, feeding, and pollination patterns created a web of interactions that linked species and environments in complex ways. These early ecosystems, intricate yet fragile, were laboratories of evolution, where adaptation and experimentation were constant. Life was now intricately entwined with the planet's surface, shaping and being shaped by soil, climate, and chemical cycles. Each organism carried with it the legacy of millions of years, the memory of oceans, rocks, and early microbial life, now expressed in movement, behavior, and reproduction. The rise of vertebrates added another layer of complexity. Fish evolved to explore shallow waters and eventually made the leap to land, becoming amphibians. Reptiles followed, mastering dry environments and gradually diversifying into a multitude of forms. These terrestrial pioneers were supported by the oxygen-rich atmosphere that plants had helped create, a testament to the intertwined nature of life and planetary processes. The memory of Earth's earliest oceans and microbial chemistry was now embedded in the physiology, behavior, and ecological niches of these animals, bridging the distant past with the emerging terrestrial world. Mass extinctions, catastrophic yet transformative, repeatedly reshaped life. Events such as the Permian-Triassic extinction wiped out vast numbers of species, but in doing so, created opportunities for survivors to diversify and adapt. Each extinction preserved memory in a paradoxical way. It recorded the limitations of certain adaptations while creating space for new strategies to evolve. The fossil record is a ledger of these experiments, a testament to resilience and renewal. The Earth's memory is written not only in continuity but also in disappearance, and every extinction leaves a mark that echoes through subsequent generations. The Carboniferous period brought swampy forests that would eventually form vast coal deposits, preserving organic material in layers of stone. These sediments are archives of past life, holding the chemical fingerprints of ancient ecosystems. Plant matter, trapped and compressed, recorded not only species composition but also climate conditions, water levels, and atmospheric chemistry. The very rocks beneath our feet are repositories of life's memory, storing information about worlds that no longer exist except in these preserved forms. During this time, symbiotic relationships became increasingly sophisticated. Fungi colonized roots, facilitating nutrient exchange with plants. Microbial communities interacted with soils and waterways, cycling nutrients and stabilizing ecosystems. These interactions were subtle, often invisible, yet they strengthened the persistence and adaptability of ecosystems, embedding memory in the very structure of the living world. Life was not solitary. It was a network of interconnected processes, each part reinforcing the stability and continuity of the whole. The oceans, too, continued their role as living archives. Coral reefs flourished, mollusks diversified, and marine vertebrates evolved in response to environmental shifts. Currents carried nutrients and chemical signals, linking distant ecosystems and creating patterns that persisted across geological time. Sediments preserved these interactions, encoding memory in fossilized shells, mineral layers, and chemical isotopes. Even as life ventured onto land, the oceans maintained a continuity of memory, a reminder of Earth's long history and the processes that sustained it. The rise of tetrapods and later reptiles marked the beginning of ecosystems that closely resemble those we know today. Predation, herbivory, and competition drove adaptations in morphology, behavior, and physiology. Ecosystems became increasingly layered and interdependent, with each species influencing the survival and evolution of others. The planet was now a co-authored narrative, geology, atmosphere, water, and life interacting in a continuous feedback loop, preserving lessons from the past while shaping the future. The Permian extinction, the most severe in Earth's history, demonstrates the fragile balance of these interconnected systems. Over 90% of species vanished, yet the survivors carried the memory of resilience, adaptation, and ecological knowledge forward. New forms of life emerged in the aftermath, including early ancestors of dinosaurs and mammals, building upon the legacies of the past. Life's memory is encoded not only in survival but in the capacity to recover, adapt, and innovate in the face of planetary upheaval. By the time the Mesozoic era dawned, the Earth had become a planet deeply imprinted with life's history. Forests, oceans, deserts, and mountains were all inhabited by organisms whose presence reshaped the environment. Each layer of rock, each fossil, each chemical signature preserved a chapter of memory, recording the successes, failures, and experiments of life over hundreds of millions of years. The planet's memory was cumulative, iterative, and persistent, embedding the past in every aspect of the present. Even today, the legacies of these ancient ecosystems persist. Coal, limestone, and fossil deposits are direct repositories of life's memory. Modern species retain physiological, genetic, and behavioral adaptations shaped by these deep histories. Life's narrative is continuous, a chain stretching back to the first oceans, the first cells, and the protocontinents beneath them. In understanding these layers of history, we recognize that the Earth we inhabit is a culmination of countless interactions, adaptations, and transformations, each preserving a fragment of memory from a world long vanished. The spread of life across continents teaches us about persistence, interconnection, and transformation. It shows that memory is not solely a human experience but a planetary phenomenon, carried in molecules, ecosystems, and geological formations. Life is both recorder and participant, chronicling the Earth's history while shaping its ongoing story. Every forest, every reef, every ancient fossil is a testament to the enduring dialogue between living organisms and the planet itself. The age of the dinosaurs represents one of the most dramatic chapters in the memory of Earth, a period when life achieved unprecedented scale, diversity, and ecological dominance. For over 160 million years, these creatures ruled the land, from the smallest feathered forms to the colossal giants that shook forests with every step. Yet even in their grandeur, they were not isolated actors. They were part of a vast, interconnected system, responding to climate, vegetation, and the chemical memory embedded in the soils and oceans. Their existence was a continuation of the experiments and adaptations of life that had begun billions of years earlier, and their legacy would endure far beyond their own extinction. The ecosystems of the Mesozoic were intricate tapestries, woven from plants, insects, reptiles, and marine organisms. Forests of towering conifers, cycads, and ferns captured sunlight, regulated the atmosphere, and created habitats for countless species. The oceans teemed with life, from ammonites and ichthyosaurs to coral reefs that preserved chemical and structural memories in their growth rings. Every organism was both influenced by its environment and influencing it in return, a continuous dialogue that etched patterns of memory into the planet itself. Dinosaurs, in particular, were agents of transformation. Their feeding habits shaped vegetation, their migrations redistributed nutrients, and their interactions with predators and prey influenced evolutionary pathways. In a sense, they were living architects of the Earth's memory, their bodies and behaviors leaving imprints that would persist in the fossil record. Tracks, nests, coprolites, and bones are more than remnants. They are tangible echoes of an intricate web of life, a biological archive preserving the rhythms of a world long vanished. The rise of mammals during the Mesozoic, though initially overshadowed by the dominance of reptiles, added another dimension to the memory of life. Small, nocturnal creatures explored niches that dinosaurs ignored, experimenting with diet, behavior, and reproduction. Though modest in size, these mammals carried with them genetic and physiological adaptations that would prove crucial after the cataclysm that ended the age of dinosaurs. Their persistence demonstrates the quiet, cumulative nature of evolution, where survival is as much about patience and subtlety as about size or strength. Mass extinctions continued to play a defining role in shaping life. The Cretaceous-Paleogene extinction, triggered by an asteroid impact, erased nearly 3/4 of all species, including the non-avian dinosaurs. Yet from this catastrophic event emerged opportunity. Mammals diversified, flowering plants proliferated, and ecosystems reorganized in ways that allowed new life forms to flourish. Extinction, paradoxically, preserves memory by selecting traits, reorganizing ecological networks, and creating space for innovation. The Earth's record is therefore written in both survival and disappearance, a ledger of lessons etched into rock, soil, and DNA. The memory of life during the age of dinosaurs is preserved not only in fossils but in geological formations, isotopic ratios, and chemical signatures. Carbon isotopes reflect vegetation patterns, while oxygen isotopes reveal climate fluctuations. Sedimentary layers record volcanic activity, sea level changes, and meteor impacts. Even the molecular structures within fossilized remains provide insights into diet, metabolism, and physiology. The planet's memory is embedded in every level, a multidimensional archive linking the past to the present. Vegetation and climate during this era were dynamic forces, shaping the course of evolution. Seasonal variations, fluctuating carbon dioxide levels, and shifting continents created diverse habitats and selective pressures. Life responded with innovation, armored plates, flight, social behaviors, and symbiotic relationships. Every adaptation was a response to both immediate conditions and the accumulated legacy of prior generations. Evolution is a dialogue across time, a process in which memory informs strategy, and each organism becomes a custodian of inherited knowledge. Even the oceans retained memory from this period. Marine reptiles, ammonites, and plankton interacted with currents, sediments, and chemical cycles. Coral reefs, shell beds, and sedimentary deposits preserved these interactions, creating an enduring record of Mesozoic marine ecosystems. The interplay between terrestrial and marine memory was continuous, as nutrients cycled between land and sea, supporting productivity and maintaining balance across planetary systems. Life and Earth were inseparable collaborators, each recording and responding to the other. The extinction of the dinosaurs reminds us that dominance is never permanent, and memory is preserved in unexpected ways. Birds, the living descendants of theropods, carry genetic and anatomical legacies of their predecessors. Mammals inherited ecological niches and biochemical strategies that were forged under dinosaurian influence. The planet itself remembers through the patterns left in soils, rock strata, and chemical gradients, all shaped by the interactions of species that no longer walk the Earth. Memory is cumulative, resilient, and adaptive, surviving even when the actors themselves are gone. Studying this era offers profound insight into the nature of resilience and transformation. The Earth's systems, climate, geology, biology, are deeply intertwined, and life is both a product and a participant in these processes. Extinction, adaptation, and innovation are all mechanisms through which the planet and its inhabitants preserve and transmit memory. The Mesozoic teaches that even in periods of apparent stability or dominance, change is inevitable, and the record of life is written not only in survival but in loss, adaptation, and the ongoing dance of ecosystems. The age of dinosaurs is therefore a meditation on scale, continuity, and transformation. It demonstrates that memory is not passive, it is encoded in behavior, physiology, ecological interactions, and geological formations. Each footprint, fossilized leaf, and shell fragment carries the weight of evolutionary experimentation, a record of trials, errors, and successes. The Earth remembers through life, and life remembers through survival, adaptation, and interaction. These lessons persist in modern ecosystems, genetic lineages, and the very landscapes we inhabit, connecting the present to a deep, unfathomable past. The rise of humans is the latest chapter in a story that began long before the first oceans formed, long before the first cells flickered into existence, and long before forests and dinosaurs walked across the continents. Our species, with its unique capacity for reflection, language, and culture, carries within it the accumulated memory of the Earth itself. Every breath we take, every thought we conceive, is built upon layers of chemical, biological, and geological history, stretching back billions of years. Humanity is both a product of the planet's memory and a new custodian of it, a conscious participant in a story that began in silence, turbulence, and the invisible currents of ancient oceans. We inherit more than physical traits. We inherit strategies for survival encoded in genes, the lessons of adaptation etched into DNA over countless generations. From the earliest primates navigating forests, to the development of bipedalism, tool use, and social complexity, humans are the culmination of a lineage shaped by environmental pressures, climate shifts, and ecological interdependencies. Our consciousness allows us to reflect upon this lineage, to trace our origins through fossils, isotopes, and the remnants of ancient ecosystems. Every discovery, every insight, is a dialogue with the memory of the Earth itself, a meditation on continuity and transformation. Language and culture amplify our ability to record and transmit memory. Whereas earlier life forms encoded experience in genes and behaviors, humans externalize memory in symbols, stories, and artifacts. We write histories, create art, and preserve knowledge in ways that extend far beyond individual lifespans. In doing so, we continue the process that life has been practicing for billions of years, transforming experience into a lasting record, ensuring that lessons, innovations, and adaptations survive beyond the immediate moment. The Earth's memory now flows through both biological inheritance and conscious reflection. Technology has expanded this capacity further. From the first tools chipped from stone to the global networks of information today, humans have become architects not only of their environment but also of memory itself. Satellites monitor climate, databases preserve knowledge, and DNA sequencing reveals the intimate story of life's history. Each innovation is a way of reaching backward and forward, connecting the present with both past and future. Humanity is now capable of observing, preserving, and even altering the memory of the Earth at a scale unimaginable to earlier life forms. Yet this consciousness carries responsibility. Unlike other species, humans can intentionally disrupt ecosystems, accelerate extinctions, and alter climates. Our actions have the potential to overwrite or erase the memory carefully preserved by billions of years of life. At the same time, we have the unique capacity to safeguard and enhance it, to restore ecosystems, document biodiversity, and preserve knowledge for generations yet unborn. In this sense, human memory and the Earth's memory are intertwined. One reflects upon the other, one has the power to destroy, and one has the power to preserve. Our awareness of geological and evolutionary time invites humility. Mountains took millions of years to rise, rivers carved valleys over eons, and oceans have cycled through warming and cooling across epochs. The life that inhabits the planet today, including ourselves, is a brief spark in a vast continuum. Yet even in this fleeting existence, we can recognize our connection to deep history, understanding that every action is part of a continuum, every thought a ripple in the ongoing dialogue between life and Earth. To walk across the Earth today is to step upon layers of memory. Fossils remind us of vanished creatures, soils preserve chemical traces of ancient ecosystems, ice cores archive atmospheric compositions, rivers and oceans carry sediments from millennia of erosion. In these landscapes, we encounter the echoes of every age, the fire of the first molten crust, the tumult of primordial storms, the slow assembly of the first cells, the rise and fall of forests and dinosaurs, and the branching evolution that eventually led to humans. Each layer, each fragment, is a testament to the patience, creativity, and resilience of life and planet alike. In reflecting on this continuum, we realize that we are not separate from the Earth's memory, we are its conscious extension. We can choose to honor it, to learn from it, and to preserve it. We can recognize that the very air we breathe, the water that flows, and the land we traverse are infused with histories beyond comprehension. Humanity's place in this story is not merely to exist but to remember consciously, to act as stewards of memory, and to participate in the ongoing symphony of life and planet. As the sun sets and the quiet of night envelopes the world, we can meditate on this connection. We are the inheritors of a narrative written over billions of years, a narrative carried in molecules, ecosystems, rocks, and waves. Each life form that has ever existed contributed a verse, a line, or a whisper to this story. We are now capable of listening, of reflecting, and of continuing this song in ways that resonate far beyond our brief existence. In the stillness of night, it is possible to feel the weight of this memory, not as a burden, but as a gift. The Earth that existed before the Earth we know has left traces in every atom, every current, every living organism. Its memory flows through us, a river connecting past, present, and future. To sleep beneath the stars is to rest within this continuum, to become part of the story that stretches from the first molten crust to the conscious reflections of humanity. And in that meditation, there is peace. The planet endures. Life endures. Memory endures. And we, for a brief moment, are awake within it, witnesses and participants in the unfolding story of the Earth. This is the gift of history, the wonder of existence, and the quiet reassurance that, though everything changes, the memory of the Earth persists, carrying forward the legacy of all that has ever been.